This bomber started with small parts being fastened together, such as by spot welding. There are no sparks in spot welding, the metals being fused by pressure and an electrical charge. This welder makes 300 spot welds a minute, so close together that they make a leak-proof seam. Applied to aircraft manufacture, Ford's spot welding technique saved 35,000 man-hours of labor per month and replaced 15,000 relatively heavy rivets in every bomber. Parts that do not lend themselves to other methods of assembly were welded by gas, and here these men and women use gas torches to join parts. Gas welding of aluminum is a highly specialized job, and scores of welders were trained in the Willow Run School. Plenty of special tools like this pressure riveter were designed for use in this work. Small assemblies for planes required much handwork, as demonstrated by this use of an air drill on one assembly phase of the tail turret well, and more dramatically shown by the building of the pilot's control column. Because of the relatively few units required to meet bomber and hour production, it would not have been practical to devise a moving conveyor line for such assembly operations as these. Assembly work was of course simplified by precision machining operations, by which formed and cast parts were shaved down almost to perfection with allowable tolerances running from only 1/2 of 1,000th of an inch to 15 thousandths. Among the small sub-assemblies, some of the more interesting originate in the plexiglass section, where windows of strange shapes were made of this light plastic. After being soaked at 256 degrees, transparent plastic becomes flexible and can be readily shaped to needed patterns. After cooling, this particular piece becomes part of the bombardier's enclosure for the nose of the ship. Dipped in this solution, it required a protective coating to prevent scratching during handling. This coating was removed later. And here workers are shown fastening aluminum skin to a stringer assembly to make a most important part of the bomber, the center wing section. And the landing gear. The spar is the main beam that runs the entire length of the center wing. The whole wing is built around it. By breaking the center wing down into sub-assemblies and by using mass production fixtures such as these, Ford cut the cycle time for building wings from 19 days to a matter of hours, from 11,414 man-hours of labor to just a few hundred. When the sub-assemblies were completed, they were swung by crane to big 27-ton vertical fixtures, the massiveness of which ensured rigidity. After the spars were in place at the bottom, bulkhead and stringer assemblies were lowered and fastened together to form the main structure of the wing. Aluminum skin was then riveted to the outside and another center wing assembly was completed. The completely assembled wing section then moved off through the air to the next operation. Faced with the possibility of a bottleneck in the machining and milling of such a large section as this wing, Ford engineers found an idea which they had used for many years in making automobiles. They designed a brand new machine shop combine known as the final machining unit. While the wing was held firmly in position, it was attacked from all directions by drills and milling tools. A simple illustration is offered by this multiple drill used to machine Ford V8 engine blocks at the Rouge plant. Note that the drills come in from all angles and drill many holes at one time. So it is with the final machining unit. Many machine operations were performed at the same time and in exactly the same position on every wing. This illustrates why every part of every Ford-built Liberator is exactly like every similar part and shows why these parts have been interchangeable from ship to ship all over the world. Cranes fed the completely machined wings to twin furnishing lines, each of which was about a city block long. Here, women workers began installation of the incredibly complicated wing wiring system. Also, the tubing clusters you saw being assembled in another part of the plant. And the 4 turbo superchargers, actually turbine pumps, which force air to the 4 engines, increasing horsepower and enabling the ship to fly higher where the atmosphere is thin. These superchargers are exhaust-driven turbines, the rotors of which speed up to an incredible 26,000 revolutions per minute. The landing gear was installed here, hooked up to its controls and tested to be sure it retracted. And so we now see the center wing section, the chassis of the bomber, completely assembled and on its way to the 4 final assembly lines. It is ready for mating to the other main sections of the bomber, which have been assembled in other parts of the vast plant. The nose section was next with its vital flight instruments, cabin for pilots, radio man, flight engineer, navigator, and bombardier. This section is the nerve center of the ship. The nose section started out with this ribbing in which the woman worker is installing a window frame. Aluminum skin then could be riveted to this ribbing to form the outer wall. Side panels for the nose, consisting of more than 500 structural parts, were attached to a conveyor and moved along an assembly line. Each of these women workers had a certain job to do in furnishing this wall with its necessary equipment, including more than 1,000 different parts. This method of assembly saved time and money because this work would take much longer if done in the limited quarters of the bomber after assembly. Here on these assembly lines, the workers could do their job quickly and easily. The pilot's floor, controls, and instrument panel was put together on a 400-foot merry-go-round type of assembly line which revolved very slowly and which consisted of 30 stations. This obviously very intricate and complicated assembly job consisted of 190 separate installations, each of which had to be a sub-assembly with a maze of detail within itself. Complete with its surrounding framework, the pilot's floor was then lowered into a special mating fixture. A crane then brought the complete sidewalls over to the fixture and placed them in position. This wall was furnished with a great deal of equipment, including an electrical harness consisting of more than a half-mile of cable. This fixture was so built that both side walls could be slid over against the framework that supported them. Then the entire unit was fastened. The cabin roof came next, followed by the canopy, called the greenhouse by flyers. Workers could then finish mating the tubes, wires, and installing other nose furnishings. Next step in assembling a Liberator at Willow Run was building the tail part of the fuselage. These boat-like objects are aft bottom panels. The ribbing was held in